Right, we've got a vector geometry problem here. This is from an IGCSE paper at Edexcel 2019, paper 1 HR. And this is quite a tricky problem at this level because it requires the formation and solution of simultaneous equations. Now, that sort of problem tends to, you'd see more likely at A level. Um, but here we've got it at IGCSE, so this is something that you should take note of, really. Right, so let's have a look. Okay, so here we've got this trapezium here. OA is equal to A, OC is C. That's there and AB is 2C. That's along there, and I've marked in red my sort of constructions here. Um, um, Q is the point on P is the point on AB such that AP to PB equals 3 to 1. So I've marked in that AP is 3 over 2C. And Q is the point on AC such that OQP is a straight line. So I've drawn that straight line in there. Use a vector method to find AQ to QC. Right, okay, so it's a very nicely, simply stated problem, which belies its trickiness, really. Anyway, yes, so what the point is here, we're actually going to want, we're interested in this point here, which lies at the intersection of two lines that we don't know either of these ratios. We don't know how far along Q is along OP, and we don't know how far along um, AC it is either. All right, so so that's the challenge with this. So I have defined the ratio of AQ to AC as being lambda and OQ to OP as being mu. Okay, and it's sort of lambda really that we want to try and get it, because once we've got lambda, then we can it's a direct step to actually the ratio between AQ and QC. Right, so we put that in. AP is equal to 3 over 2C. Now AC, which we'll need, is AO plus OC. AC is just taking the journey via O. That's what we're doing with this statement here. And since AO is minus A and OC is C, then AC is C minus A. And OP, if we take the journey via A, we're going OA plus AP. OA is A, AP is 3 over 2C. Okay, so that's all the sort of the prerequisites done with. Um, First of all, then let's find AQ using lambda. Well, that's fairly straightforward because it is just lambda AC, and we've worked out what AC is up here. So it's going to be AQ is lambda AC equals lambda C minus lambda A. Okay, so I've written that expanded for reasons you'll see in a moment. And then we want to find AQ using mu. Well, AQ via O is minus A plus OQ, and OQ is mu times OP. So AQ is minus A plus mu times this thing here that we've got from up there. So again, separating the A and the C parts out, we can rewrite this as this mu minus 1 A plus 3 over 2 mu times C. Now, the kind of fundamental step here is the fact that uh, the coefficient of A in this version has got to be equal to the coefficient of A in that version. And the coefficient of C in this version has got to be equal to the coefficient of C in that version. That's the sort of the kind of fundamental principle that we're working with vectors. So we can equate those coefficients, and when we do that, we basically get that equating the A components, and we get that equating the C components, which converts into that. So now we've got something with this that we can substitute into equation 1, giving us that, and that in turn gives us lambda equals 3/5. All right. So if lambda is 3/5 of the whole lot, then it's going to be 3 to 2 AQ to QC. So that is the ratio that we're looking for. AQ to QC is 3 to 2. We can also see from this that mu is 2/5, so therefore OQ to QP is equal to 2/5. Okay. Sorry, OQ to QP is 2 to 3. Okay, but the answer we're looking for is this ratio, 3 to 2. Okay, so hopefully that has been clear and useful. It is a kind of a useful thing worth knowing. So thanks for listening.